To describe various processes in nature, we need a frame of reference. In classical physics, a frame of reference is a coordinate system with a clock. We deal with reference frames always. For instance, if we measure some physical quantity, temperature, speed, or whatever you want, the result is its value in the frame where the measuring device is at rest. Since a coordinate system is coordinate axis connected to an object, different frames are likely to move in respect to one another. According to Galileo's principle of relativity, if two frames have constant relative velocity, then the laws of physics are the same in both frames. While solving a problem, we have an opportunity to choose the frame which is the most suitable for us. Newton's law allows us to pick some particular frames out of all existing, such that the laws of physics have notably simple forms. These are so-called inertial frames. Galileo's principle tells us that the existence of an inertial frame means there are infinite number of inertial frames which have constant relative velocity in respect to the first one. Inertial are often called the frames where Newton's first law holds, but in fact, in Newtonian mechanics, it's important to call inertial the frames where all three laws hold. Let's remind you Newton's laws. According to Newton's first law, if an object experiences no net force, then it is traveling with constant velocity or it's at rest. This law is also called the law of inertia. According to Newton's second law, if an object experiences a force, then its acceleration is directly proportional to the force and is inversely proportional to the mass of the object. But you may have already guessed that the first law can be derived from the second. Really, if the net force acting on the object is zero, then the object acceleration is zero, hence it moves with constant velocity. A question arises, why Newton has stated them as different laws and what contribution does the first law have to picking out inertial frames? Newton clearly knew that his second and third laws cannot be true in all frames, so he needed to emphasize that there are such frames where all his laws are true, namely, the law of inertia does this job of emphasizing. Before going to Newton's third law, let's show an example of non-inertial frame. Consider a tree which is at rest in an inertial frame. Now, consider a frame which is moving by acceleration to the right. In this frame, the tree is going to the left by the same acceleration. For an observer in accelerating frame, appears that there is a force acting on the tree because according to the Newton's second law, acceleration is caused by a force. These kind of forces which arise in non-inertial frames are called forces of inertia. They are not forces caused by interaction. According to Newton's third law, for every force there is its couple equal in its magnitude and opposite in direction. This means that in Newtonian mechanics all forces are forces of interaction.